Welcome you all to the session on system software. Today just I am going to discussing about the pass1 assembler algorithm. So in the last class we had a discussion on why for processing that process, why it is needed to what different phases, that is pass1 and pass2. So in a single pass it is not possible to convert the entire program into object file in a single pass. So for such kind of things, because due to some kind of forward references, as we know that, so when we have written that program by using the assembly level language program, so the instructions will be written first, and after that only just we are going to defining the memory variables what we are using in that particular program, isn't it? So in this case, when the assembler encounters any kind of instructions, it is searching for the variables or the operand field what actually it is using in that particular instruction. So it is defined in somewhere else in that program, directly it cannot jump to that particular instructions to get the value. So means in a single pass it is not possible to get an object code for the instructions. So what other instructions just we have written by using assembly level language. So for such kind of things it undergoes different kinds of passes, pass 1, pass 2 up to multiple passes, just depending on what kind of instructions it is. So here just we are going to discussing about the pass 1 and pass 2 algorithm in this today's session. In two pass assembler there are two passes are there is pass 1 and pass 2. To overcome the difficulties of pass 1 and pass 2, so then they were designing that one pass assembler. We will discuss that one pass assembler in the later session. So here in the pass 1 and pass 2, during pass 1 what actually it is going to be done is, so just it is going to assigning the address to all the instructions of that program what the user has given. So accordingly what the address just we have mentioned in the starting address, assembler it will take that starting address, then it is going to assigning the address for all the instructions one by one in the form of hexadecimal format every time. So since just we are discussing about that SIC assembler here, assembler algorithm here. So since it is SIC assembler, so here the instruction format, the instruction length of any instructions it is of 3 bytes length. Every time the location counter value it is going to be incremented by 3 bytes like that. So during pass 1 what actually it is going to do is the three main data structures which we are using, already we have discussed all these things. One is opcode table, second one is symbol table, and third one is locator counter. Locator counter is nothing but it is working in the similar way of the program counter. So the opcode table it is static. It is static one. It is static one. The same opcode table it is going to be used by pass 1 and pass 2 assembler. Both assembler is going to be used that opcode table. It is static, it is same. So what is opcode table? It is having all the informations about the opcodes of all the instructions, what the instructions the user is going to use to write the program. So next opcode table, along with that it is having memory operations and whatever the variables which are involving in that particular instructions or operations and all. It holds all kind of in which format that instruction is there, if it is SIC, XC, like that. So every information will be there in the opcode table like that. So but in this case in the symbol table it is dynamic one. So means during pass 1 just it is going to be created by the pass 1 assembler. It is a dynamic table which holds the informations about all the label fields which are present in that program along with its value. Its value means the locator counter value, that is the label name and the value of that particular label. So means the label name means whatever the assembly level language program just we are taking, that entire program it is having three different fields. One is the label field, mnemonic field and the operand field. So during pass 1 just it is going to touch only that label field and the mnemonic field. During pass 2 it won't touch that label field, just it is going to process that mnemonic field and the operand field to get an object code. Actual translation is going to be done at pass 2. And another one is location counter is nothing but it is holding the value or address of the instruction is to be fetched out to be executed, like, right. So these three data structures which we are using in while designing any kind of assemblers. So during pass 1, it is going to assigning the addresses to all the statements in the program. So then it is going to save all the values assigned to all the labels for use in pass 2 in the form of symbol table. So perform some processing of assembler directives. If any assembler directives we are using, just it is going to process such kind of assembler directives. So during pass 1, what actually it is going to do is, so just it is going to process that label field and the mnemonic field. Label field, if the label field, it is any symbols which is there in the label field, what actually it is going to do is, it is going to enter that label name into the symbol table along with the location counter value. If no labels are there, just it is going to skip that one. So once the label field is scanned, what is the next field is the mnemonic field. So just it is going to identify whether the mnemonic value it is valid or not. It is actual translation is not going to be done by during pass 1. Just it is going to what identifying whether the instruction it is valid or not, like that. So next, during pass 2, actual translation is going to be done at during pass 2. So pass 2, what actually it is going to do is, it is going to assemble what instructions by translating the opcode and the symbolic operands. During pass 1, it is using the opcode table for verifying the instruction whether it is right or not. Sometimes when the user is typing some kind of instructions, is missing something, or otherwise is going to write some kind of wrong instructions. So just for that, for verifying whether it is valid instructions or not, so during pass 1 it is going to using that opcode table for that. During pass 2, the same opcode table it is going to be used. It is going to be used during pass 2 for actual translation. So here assemble the instructions by translating the opcode and the operand address. Translating the opcode, it is going to get the value from the opcode table. For translating the address, it is going to get the value from the symbol table which is being created by pass 1 assembler. So next it is going to generate the data values defined by using the byte and word. So as we know that the assembler directives, there are different kinds of assembler directives just we are using. Just it is generating an object code for only that constant values, that is the byte and word. So byte and word float like that. So it is not going to generate any kind of object code for reserve byte, reserve word, like for such kind of assembler directives it is not generating any kind of object code. So next it is going to performing of assembler directive which is not processed at during pass 1. Next, finally it is going to write the object code to the object file by using the listing line. So this is how actually during pass 1 and pass 2 is going to be used. So already I explained all these things from input line. Just what actually it is taking, it is label, opcode and operand. Label, opcode is nothing but the mnemonic value, operand is nothing but is a symbolic value. So it is using 3 different kinds of data structures, that is the operation code table, that is the op table. So next one, symbol table, it is a dynamic one. It is a dynamic one, and location counter, it is a special type of registers which holds the address of the next instruction is to be fetched out. So during pass 1 it is using the opcode tables to verifying whether that instruction is right or not. So next it is going to what, just we are giving that source program as an input. So just it is going to process that source program line by line in the sequential manner. So for verifying whether it is right instruction or not. So if any labels are there, if any symbols are there in the label field, just it is going to enter all the labels into the symbol table along its value. So then it is going to generate the symbol table. That symbol table, it is having all the entries of the symbols which we are using in that particular program. So as we know that whatever the memory variables which we are using in that program, every memory variables which are there, which are defined within that label field. If it is not there, the variable it is not defined like that. So then it is going to generate the intermediate file. The intermediate file, it is having the value, means it is having the address of all the instructions along with that label field and the mnemonic field. Along with also it is also sending that symbol table for the pass 2. The pass 2, it is using the intermediate file along with the opcode table and the symbol table. The symbol table is which is being created by the pass 1 assembler. The same symbol table is going to be used by pass 2 for translating. So finally it is going to generate an object code. So already explained all these things. Opcode table, it is in the form of hash table structure. It is the content, it is the mnemonic and machine code, instruction formats, instruction length and memory variables which are there in that particular program, and it is a static table. It is implemented by using arrays or hash table, easy for search by using its instruction name. Just we can search if it is valid instruction, that it is there in the opcode table. If it is not valid, it will not be there. So then it is going to return it is not there, then it is going to set an error flag for that. So here the symbol table, it is nothing but it is a dynamic table. Just it is going to be updated, it is changing from one program to another program, because the same label name just which we are not using in every program. So in every program that symbol table, it is going to be changed. So here it is having the label name along with the value. It is in the dynamic table, that characteristic implementation, again just we are using the hash table. So here just we are searching for that particular label by using its name. So just to get that value of that particular just from the symbol table, just we are getting. So just I want to explain that pass1 assembler of 2-pass assembler. It is very important, simple thing. So the only concept is, when we are giving an source program as an input to an assembler, that is the pass1 assembler, what actually it is going to do is, first it is going to scan the entire program line by line in the sequential manner. So when it encounters the first line, so first it is searching for the label or symbols which are present in the label field. So if any symbols are there in the label field, so what actually it is going to do is, it is going to copying that label name into the symbol table along with the location counter value. If no symbols are there, then next to move to that next field. What the next field it is there? The mnemonic field. So mnemonic field, what actually it is going to do is, for example, if I am writing that mnemonic value as add. So here just it takes that value, it takes that mnemonic value, then it is going to searching the same add instructions in the opcode table, whether it is there in the opcode table or not. If it is there in the opcode table, then it is a valid one. If it is not there, it is not valid. For example, while I am writing that add, just I am missing one D here. So just it is taking that AD, that is add, then it is searching for that instructions in that opcode table. In the opcode table, it is a predefined, it is having all the instruction set within that along with the opcode values, along with the memory structure and all. So it is there? No. If it is not there, means it is the invalid input or invalid instructions. So then it is going to set the error flag. So it won't touch any kind of mnemonic field. For example, in the instructions on whatever the program just we are taking, so the first instruction, it is first STL return address. So here this is the label field, this is the operator or the mnemonic field. This is the symbolic field, we can see. During pass1, what actually it is going to do is, suppose the locator counter value at that time, it is going to be set to be as 1000. For this instruction, it is going to assigning the value 1000 like this. So first it is searching, it is encounters the symbol which is present in the label field. So if it is present in the label field, what actually it is going to do is, so the same label name we cannot give for more than one instruction. So what actually it is going to do is, whatever the label name just we are using here, that just it is going to checking for that label name in that symbol table or not. So whether it is present in the symbol table, no. So what actually it is going to do is, if it is not there, it is going to enter that label field into the symbol table. So then it is going to searching then along with the value of the location counter. So what is the value of the location counter? It is 1000. So during pass2, to get the value of the first or return address and whatever it might be, so then it is going to get that value from the symbol table. So after finishing that one, what is the next field? It is the mnemonic field. It is going to search that mnemonic value. It is taking that STL which is present in the opcode table or not. It is going to searching for that. So if it is there in that opcode table, means it is valid one. It won't do anything. Just it is going to processing whether it is valid or not. If it is valid, so simply that locator counter value, it is going to be incremented by 3 for the next instruction, because since it is SIC machine or SIC algorithm, right. So means every time the location counter value must be incremented by 3, incremented by 3. So means after that, then it is going to pointing to the next instruction. Then it is going to searching for any symbols which is present in the label field. Yes, if it is there, it is going to searching in the symbol table whether that symbol is already present in the symbol table or not. If it is not present, then it is going to write the symbol into the label, into the symbol table along with the locator counter value, like that. Right. So you can observe that in the mnemonic field, whatever the mnemonic field it encounters, in that mnemonic field, either we will get the instruction set, otherwise we will get that what we got an assembler directives. Whatever the assembly directives which we are using, those assembly directives which are not present in the opcode table, which are not present in the opcode table. So just it is going to verifying whether it is valid assembly directives or not. So what actually it is going to do is, first it is going to get that if it is byte means it is a character or string. It is a character array or string we can say. So just it is going to observe that whatever the value which is present in the mnemonic field and how many bytes it is needed. How many bytes is needed, just accordingly just it is going to incrementing that byte value or what the word value. So if it is byte, it is going to increment it a single byte, it is depending on the number of what bytes which required for that particular thing. Otherwise it is going to increment, if it is it is going to be incremented by 3. If the location counter value, so here in the mnemonic field either it will get the mnemonic value or the assembler directives. If it is a mnemonic field, what actually it is going to do is every time the location counter value it is going to be incremented by 3, because the instruction length it is 3 bytes only. So after that, once it encounters anywhere that assembler directives, what actually is going to do is first it is going to check whether it is valid assembler directive or not. So if it is valid, then it is going to identifying what kind of assembler directive it is. So if it is byte, so then it is going to checking how many bytes it is required, 2 bytes, 3 bytes, up to n number of bytes. Accordingly that location counter value must be incremented. So if it is word, it is going to be incremented by the number of words, like that. Just I explain later in the same algorithm, just what we are taking. So this is how actually it is going to be done during pass 1. Pass 1, so just it is going to constructing the symbol table for the pass 2 assembler, along with it is also use the opcode table for verifying whether the instruction what the user has written it is valid or not. So this is going to be done during pass 1. So then it is going to create the intermediate file. That intermediate file it is having the address of all the instructions along with the source code. So it will be there in the intermediate file. That intermediate file will be the input to the pass 2. So now just I want to explain that algorithm now. So just I will take the same program here to explain that algorithm. Just I will take the same program. So here during pass 1, what actually it is going to do is, first we are going to check if the opcode of the first instruction, what is the first instruction is there. So what is the first instruction is there in that program. So that is program name, that is the copy, start assembler directives, what is address, just we have mentioned is the 1000. So what actually it is going to do is, just it is going to read the first input line. So what was the first input line in that program? This is the first input line. This is the first input line. So after that, what actually it is going to do is, directly it is getting to that opcode. So if the opcode is equal to start, yes of course, if opcode is equal to start, what actually it is going to do is, it is going to save the operand. Operand means this one. This is the operand field, this is the mnemonic field, this is the label field. So if opcode is equal to start, if this condition is true, what actually it is going to do is, it is going to save the operand address as starting address of that program. Initialize the location counter value as 1000 here. initialize the location counter to starting address. What is the starting address? It is 1000. What is the starting address? It is 1000. So next what actually it is going to do is, it is going to create the intermediate file. It is going to create that intermediate file. Just it is going to write the line to intermediate file. What is the line it is there? That is the copy, then start 1000. So just it is going to write the what? First line into the intermediate file. Else if opcode is equal to start, if the user has mentioned the starting address by using the start assembler directive, then we have to say that starting address is its operand address. Else we are going to initialize the location counter value as 0. But here just we have mentioned the starting address, start assembler directives. What is the starting address is 1000. The starting address of that program is been started from the 1000 memory location only. Is it clear? So next after that, what I need to do is, I want to process all the instructions until it encounters the last statement. So you can observe that in the program just what we have taken here. So just you can observe that the program is being started with the start assembler directive and is been ended with end assembler directives. Just you can observe that it's been ended with end assembler directives. So here what we need to do is, so just we have to process all the instructions from start to end one by one. So for that just we have to put into that while loop. So here just we have to, while opcode is not equal to end, just we have to process all the lines. We have to process all the instructions until it encounters the end. So once it encounters the end, it comes out from the loop. It has to process all the instructions until it encounters the end statement. So what actually it is going to do is, while opcode is not equal to end, what is the next statement? What is the next statement which is there? So which is there at the memory location, means the next instruction it is first in the label field. The instruction it is first STL return address. This is the second instruction which is there. So then it is going to check the opcode is equal to end. No. Opcode is equal to end. No. What is the opcode? STL. So if this is not a command line, so leave it. If this is not a command line, no, it is not a command line. The command line which is been started with dots. The command line in the assembly level language, it started with dots. So next after that, what actually is going to do is, if there is a symbol in the label field for the second instruction, still the location counter value it is 1000 only. Still the location counter value it is 1000 only. What actually it is going to do is, if there is a symbol in the label field, is there any symbol in the label field? Yes. What is the symbol name? First. So what actually it is going to do is, it is going to construct the symbol table here. Symbol table, that symbol table it is having the locator counter value, it is 1000. It is going to construct the sim table or symbol table. That symbol table it is having all the entries of the label name and the value. What is the value? That is the location counter value. What is the value? That is the location counter value. So what actually it is going to do is, if there is any symbol in the label field, yes, that is symbol which is present. What actually it is going to do is, the same symbol name we cannot give for more than one instruction. It is showing some kind of illegal memory access. Right? So in this case, what actually it is going to do is, it is going to searching for that symbol in the symbol table. It is already there in that particular symbol table or not. So first, what is the symbol we got in the label field? First is already there in the symbol table? No. So if there is a symbol in the label field, then it is going to search the symbol table for that label. What is the label name? First it is there in the symbol table? No. So if found means what? So means we are giving the same label name to more than one instructions, means it causes some kind of illegal memory access. We cannot give that, such kind of things. If found means if it is already there in that symbol table, then it is going to set the error flag, that is a duplicate symbol. If it is there in that symbol table, no. then it goes to that else part. What actually it is going to do is insert that label name into the symbol table. What is the label name? That is the first symbol table along with the locator counter value. What is the locator counter value? It is 1000. It is entering that locator counter value as 1000 into the symbol table. So after that, once the label field is been done, what is the next field which is there in the same instruction? It is the mnemonic field. So next it will go to that search opcode table for the opcode. What is the opcode which is there? STL. That STL is a valid instruction. Since the STL it is a valid instruction, so then it is going to searching for the STL which is present in the opcode table or not. Your actual translation is not going to be done. It will not convert that mnemonic field into opcode. So just it is going to searching for that particular mnemonic value into the opcode table, in the opcode table. So if it is there, it is a valid one. So simply it is incrementing the location counter value for the next statement like that. So means what is that STL? STL it is present in the opcode table. Since it is valid one, yes of course it will be present in the opcode table. So if it is opcode table, if search the opcode table for the opcode, if found, so just we have to add 3 to the locator counter because the instruction length, because it is SIC machine architecture, the instruction length it is of 3 bytes. So since it is SIC assembler, simply we have to add 3 to location counter value. So means what is the location counter value now? It is 1003. So if this condition is true only, search the opcode table for opcode, if found, it won't go that else part. Why this else part it is? So whatever the mnemonic field it is there, either it might be having the actual mnemonic value, or it might be having assembler directives. Assembler directives like word, byte, reserve byte, reserve word, like that. These kind of assembler directives will be there. So if it is the actual mnemonic value, it won't go to that else part because it already got that one. If it is not there, so then it is going to searching for whether it might be word or reserve word, byte or reserve byte, like that. So suppose if the user enters some kind of invalid instruction, instead of STL, if he has entered ST, so what actually is going to do is it is going to searching for that ST in that what opcode table, whether it is present or not. So if it is not present means it is going to what searching? Yes, of course it might be what an assembler directives. No, it is not any kind of assembler directives. So then what actually it is going to do is it will go to this else part, then it is going to set the error flag, that is the invalid opcode. In the opcode field, in the mnemonic field, either it might be a mnemonic value or some kind of assembler directives, otherwise some kind of wrong instruction. If it is wrong instructions, it is not present in the label field like that. So next it is going to write the same line into the intermediate file. What is the next line? It is first along with the location counter value 1000 at the memory location, first STL return address. So within that same program, next it is going to read the next input line. So what is the next input line in the same program? So what is the next input line? So here C loop, JSUB, redirect. So just you can observe that it won't touch this operand field anywhere. It won't touch any operand field anywhere here in the during pass 1. So what is the next statement? It is C loop, that is JSUB redirect. What actually it is going to do is, so now what is the locator counter value now? It is 1003. So what the C loop is already present in the symbol table. First it is going to check whether that opcode table, whether that opcode is not equal to n, S, this is not a comment line, S, if there is a symbol in the label field, S, there is a symbol in the label field. What is the symbol name? That is the C loop. C loop is already there in the symbol table. If there is a symbol in the label field, so then it is going to search the symbol table for that label. If it is found, so then it is going to set the error flag, otherwise it is going to enter that label field into the symbol table along with its locator counter value 1003. Along with its locator counter value, means that C loop which is available at the memory location 1003 at the what assemble time it is showing for the assembler. So after that what actually it is going to do is, so then it is going to search the opcode table for this opcode. JSub, it is there in the opcode table, so hence it is a valid instruction. For that it is going to add to the location counter value, it becomes 1006. So next, if this condition is true only, so it won't go to that else part, directly it is going to write the line to the intermediate file at the memory location 1003, that is the C loop. What is that? JSub, then what is that? JSub redirect. So then it is going to be what? Process all the lines like that only. So once it encounters, just you can observe that. So when it comes to this point at the memory location 102A, at that time the location counter value, it is 102A only, 102A. So what actually it is going to do is, so just it is going to searching for the label field EVOF. EVOF is already there in the symbol table? No. So then it is going to enter that EVOF into the symbol table along with its location counter value 102A. 102A, just I am skipping all those instructions, just you have to trace it out. So right, 102A. So after that it is going to searching for that mnemonic value. What is the mnemonic value? It is byte. Byte means it is not actual mnemonic, just it is going to searching for that opcode table. What actually it is going to do is byte. If it is there in the opcode table, no. If it is there in the opcode table, no. Then what actually it is going to do is, so you found, search the opcode table for the opcode. What is the opcode it encounters? Byte. Byte is there in the opcode table? No. So next what actually it is going to do is, it is going to identifying what kind of assembler directive it is. Whether it is byte, reserve word or word like that. So else if opcode is equal to word? No. Opcode is equal to word? No. So then it is go to that this else if part. So if opcode is equal to reserve word? No. Else if opcode is equal to reserve byte? No. Else if opcode is equal to byte is this condition is true. Yes, that condition is true. So then it is going to find the length of the constant in bytes. So for example, in that instruction, in that program, what is the length of that one? What is the character string it is having? EVOF, that is the character string, it is EVOF. How many bytes are there? For single character it requires 1 byte, so means 3 bytes. It has to find out the length of that one. So what is the length? It is of 3 bytes. So just it is going to find the length of the constant. What is the length of the constant? It is bytes. So it is 3 bytes. For that just we have to add 3 to location counter. If the string length it is of 11 bytes, we have to add 11 to the location counter. If the string length it is 10 bytes, we have to add the 10 to what location counter value like that. So means what actually it is going to do is, so just we have to add, what is the length of that byte? It is 3 bytes. Simply we have to add 3 to that location counter value. 3 to location counter value, 10 plus 3 it is 13. 13 is nothing but it is D. 102D for the next instruction. So after that, then it is going to write the same line into the intermediate file for the for the pass to algorithm. So in this way just it is going to process all the instructions line by line. So once it encounters the end, it comes out from the loop. So then it is going to write the last line to the intermediate file. Finally it is going to find saving that locator counter value minus starting address as the program length. So in that program just you can observe that what is the locator counter value for the last instruction it is 2079. When it encounters the end, so your plus 1 will be added, so that is 207A. So what will be the starting address? 1000. So then to get the program length, that is object program length, so then we have to subtract the starting address from what? Starting address from this instructions from that the last address. So then we will get the actual length of that one, that is 1078 is the length of that program. So this is how actually that what pass one algorithm of 2 pass or 2 pass assembler will work. 1 pass assembler is different, 2 pass assembler is different. 2 pass, it is 2 passes are there, pass 1 and pass 2. In 1 pass, in a single pass only everything is going to be done. So in this during pass 1, please observe that, please do remember just it is going to process only that label field and the mnemonic field, the label field for constructing the symbol table, the mnemonic field, whether it is a valid mnemonic field or not, like that. So either in the mnemonic field, either it will get, so what actually is going to do is, first it is going to get that symbol, any symbols in the label field, just it is going to searching in the symbol table for that label. If it is present, means it is going to set the error flag, otherwise it is going to enter that symbol name into the label field, into the symbol table along with the location counter value. So then it is going to verifying that what instruction, whether it is a valid one or not, by verifying the instruction name in the opcode table. If it is there, it is a valid one, then it is going to add only that 3 to that location counter, because that instruction length, it is 3 bytes. So if it is encounters that any kind of assembler directives, if it is word, reserve byte, of byte, and whatever it might be, it is going to finding out the length of the things what actually it requires for that constant and reserve areas. So accordingly that location counter value is going to be incremented. So every time it is going to write that line, after processing each and every line, it is going to write the same line to the intermediate file. For that intermediate file will be the input to the pass-to algorithm. So here that finally it is going to finding out the the length of that object file for processing it. So here this is how actually that pass1 assembler algorithm will work. So just I am winding up this session now. We'll continue that pass2 in the next session. Thank you.